Hi, I'm David. A P0300 is a non-cylinder specific misfire DTC. It occurs when the ECM detects a crankshaft rotational speed variation, enough to cause excessive emissions. In this module, we'll look at how to diagnose the causes of a P0300. Each time a combustion process occurs, the crankshaft will accelerate due to the expanding gases. The ECM is able to detect this variation in crankshaft rotational speed. By monitoring variations in the crankshaft rotational speed for each cylinder, the ECM can detect individual cylinder misfire events. First, determine from the customer the conditions under which the fault was noticed. If there are other DTCs present, these should be dealt with first. A P0300 can be present without an actual misfire taking place. Driving on a rough road is often enough to cause a crankshaft speed variation. Many vehicle manufacturers use the wheel speed information or rough road sensors to prevent the DTC from occurring under these conditions. Defective drive belts or abnormal engine noises are another possible cause of a P0300. A loose or incorrectly installed engine automatic transmission flex plate, engine flywheel or crankshaft balancer may also set this code. Once it's been determined that the code is set by a misfire, a logical sequence needs to be followed to find the fault. Before doing any diagnosis, it's important to perform any crankshaft sensor learn procedures for the vehicle you're working on. The battery needs to be fully charged and in good condition. When disconnecting connectors or removing fuses, always check for the correct terminal tension and for corrosion. With the engine running at normal operating temperature, make sure there are no abnormal engine noises. Using a scan tool, check the misfire counters. This will help you determine if the fault is on just one cylinder or multiple cylinders. If there are no misfire counters on the scan tool, try operating the vehicle under the conditions of the freeze frame records. If you don't have access to this information, try operating the vehicle under the conditions reported by the customer while checking the misfire counters. With the scan tool still connected, check the long-term fuel trims. A high positive reading indicates a lean mixture and a high negative reading indicates a rich mixture. If you're dealing with a fuel misfire, it's important to know whether you're running rich or lean. Now let's have a look at the injector harness. Make sure the connectors are secure and on the right injector. It is possible on some engines to swap the injector leads. This won't cause a problem on grouped injection, but it could be a problem for sequential injection. Examine all the vacuum hoses and seals for intake leaks. Don't forget the throttle body and seals. I'll use a leak detector because it makes this job so much easier. First of all, I check to see that I've got my smoke, which is okay. I'll plug it in and then I go looking for any signs of smoke. And there we can see we've got a leak. Check the air filter for excess contamination. Check the fuel pressure by connecting a gauge and starting the engine. Compare the results to the manufacturer's specifications. If the pressure is too low, then check for restricted fuel lines, fuel filter or strainer. Inspect the harness connectors and the ground circuits of the fuel pump for poor connection. If the pressure is too high, then check for a restricted return line or faulty pressure regulator on a fuel return system or the fuel pump on a returnless system. Fuel contamination should also be checked. A sample should be taken from the bottom of the fuel tank. Contaminants can include particulate matter, water, or excess alcohol. Here I've got a sample of fuel. If your fuel looks like this, it's got water in it. I've got here another sample of fuel. We can see there's no contaminants in there, but what about the alcohol content? What I've got is two measured marks. Each of them is 100 mils. So I've got 100 mils of fuel, and I'm going to add 100 mils of water. Put the top on, give it a shake, and now I've got to wait for it to settle. Now that it's settled, you can see I've got 100 mils of water and 100 mils of fuel. There's no alcohol in this fuel. It's purely unleaded. I've got another sample of fuel, and we'll do the same test. 100 mils of water into 100 mils of fuel. Give it a shake and wait for it to settle. Now that it's had a chance to settle, we can see that we have a very different result this time. We have a small amount of fuel at the top. The ethanol that was in the fuel has now mixed with the water and separated. This is E85. If you put it in a non-flex fuel vehicle, it won't run very well at all. An extreme restriction in the exhaust can also cause misfire DTCs. Possible causes are damaged or crushed pipes and blocked mufflers. Check the ignition system. Check for open circuit wires, cracked or damaged boots. Check the spark plugs. Remember to keep them in order and pay particular attention to any that have a different appearance. Test the spark by using a high-energy spark tester. Referring to the correct schematic for your vehicle, check to see that each ignition coil is receiving the correct voltage. Then check each coil for the correct ground. If possible, use an oscilloscope to check the primary pattern and the secondary pattern and replace any defective parts found. That wraps up our look at diagnosing P0300. The procedures don't have to be followed in this exact sequence. Start with one system and explore all possibilities before moving on to the next system. Following this approach will make sure that nothing gets missed. Once the fault is repaired, remember to do a drive cycle and recheck for DTCs. And always remember, training is the key to your success. Bye for now.